Trigonometry, Chapter 5, Trigonometric Identities. Section 2, Verifying Trigonometric Identities. Video 3, Verifying an Identity, Example 2. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Unlike previous series of videos, these are not connected from one to the other. This is just a sequence or a sequence of verifying trig identities. So let's get right into it. Maybe. Verify the identity. 1 minus sine squared beta over cosine beta equals cosine beta. Remember, we have two basic strategies at this point. Number one is to start with the more complicated side and try to turn it into the less complicated side. And number two is to turn everything into terms of sines and cosines. And by the way, that second approach is not always the most efficient approach. In this case, it's already sines and cosines, so let's just see what we can do. Now, let me tell you what not to do first. What some people will try to do is treat this like an equation that you're solving, in the sense that you will want to do things to both sides of the equation. For example, if you were solving an equation, a good strategy would be to multiply both sides by cosine of beta to eliminate the fraction on the left. However, that is not an option here. Why is it not an option? Because we are trying to verify that this is a true equality, that this equation is true. When you multiply both sides of an equation by something like this, you are doing it under the assumption that it is already true. So we are doing a move that is already assuming that the identity is true. As a consequence, purge this from your plan of attack. When you're verifying identity, never do a move to both sides of the equal sign. That's under the assumption that it's already equal, which we're trying to prove. Instead, manipulate one side to turn it into the other. There's a variation of that we'll see later. So we're going to try to take the left side and turn it into the right side. So let's start with 1 minus sine squared of beta. Now, when I look at this, two things jump out at me. Number one, as a fraction with a single denominator, I could split this into two individual fractions and then manipulate it. Or, the other thing I see, the numerator is a binomial with a squared trig function. Binomials with squared trig functions are indicators of a Pythagorean identity. And if you know your Pythagorean identities, you'll know that 1 minus sine squared is just cosine squared. Again, that's a Pythagorean identity. And one thing I didn't mention in the previous video is that every time we do a trig move, use a trig identity, I cite it by saying, in this case, PI for Pythagorean identity. Now, if you do an algebra move, there's no need to cite it. I guess you could just say algebra. For example, cosine squared of beta over cosine of beta collapses down to cosine of beta. So if you wanted to justify that move, you could just say algebra. But I'm not going to require you to cite every time you do an algebra move. But for students in my class, when you verify an identity and use a trigonometric move, such as a Pythagorean identity, I will ask you to cite the identity that you're using. And something as simple as PI would suffice. And then we're done because we reached our goal. We turned the left into the right. Ta-da!